Hey, good morning, Radnor Elementary School. Mr. Serpico checking in for another math lesson. We've got a couple left here. Today, we're going to talk about understanding and measuring volume. We've been doing a lot of this lately. We had a Nearpod lesson that's very similar to this one, actually about a week ago. But I know some of your teachers have been introducing volume a little bit intermittently during IE because we knew that theoretically volume is supposed to come up after PSSA, and yet you were going to be assessed on that. Of course, this pandemic came and it certainly did change all of our plans. But today we're going to talk. It's a 2-day lesson. I'm going to go about halfway through it. Try to go quickly here because I know you guys are doing a really solid job, pardon the pun, on volume. But we're going to take a look at a couple different ways you can compose and decompose figures, looking at oddly shaped 3D figures, and looking at more traditional prisms and calculating those measurements. So in this slide, it's kind of going over the objectives, finding volumes of cubes, rectangular prisms, which we've done, finding the volume of a solid constructed figure from unit cubes, which is really visual. You guys should have a good time with that. And then comparing volumes of cubes, rectangular prisms, and other objects. So let's look at a few objects and let's try to determine which one has a greater volume. So evaluating this conversation here, watermelon takes up more space than the orange. This is because the watermelon has a greater volume than the orange. So that image just has the two kids there looking at the refrigerator. And of course, the whole refrigerator and freezer, they have the capacity for volume. So if we were in the classroom, we would talk about how area and volume are different. When you think about area, you think about a 2D space. Your length and your width are your dimensions, or your base and your height. You're finding out how much wood you need to cover a floor. You're finding how much grass seed you need to cover your lawn. When you think of volume, with this pandemic, my wife and I were anticipating not being able to go to the beach very much this summer. We also have a pool membership at the local YMCA. So you can probably imagine where I'm going with this, but getting relief from the heat was something that we were concerned about. So we bought an 18-foot diameter circular pool, and I guess it's more of a cylinder if you think about it, because it's above ground. You inflate it and you fill it. It's about 5,500 gallons, so 5,500 gallons of liquid volume. So how are they different? When you think of volume, you're not just going length and width, you're also going height. So it took us about, I want to say, close to 24 hours to fill that pool. And volume is typically significantly more than area, if you're talking about the same amount of space, because you're going your length and your width dimensions, and you're also going your height. And what is the corresponding unit of measurement for volume? So volume can be measured in cubic units. It can be, liquid capacity. So we'll take a look at some examples. And here's one here. So we're comparing the volumes of some 3D objects. Which object has a greater volume? In scenario one, you've got the baseball or the football. Second one, you've got a gift box or a carton. And then the third one, you have a basketball or a can of soup. And the teacher clue here is the volume of an object is the amount of space it occupies. So the amount of space inside. In this case, the first one, the football is filled with air. The softball, rather, is filled with it's got like a rubber core, and then it's got string like a twine going around and around. So go ahead and take your guess on these three objects. Pretty straightforward, just kind of a warm up. Which is the greater volume? Pause right here and guess. Okay, so for the first one, you probably guessed the football. For the second one, you probably guessed the carton. And for the third one, you probably guessed the basketball. Pretty easy, right? Especially with the images. On this slide, the learn is find the volumes of cubes and rectangular prisms in cubic units. The volume of a cube or rectangular prism is the number of cubic units needed to make it. This image right here is a cubic unit. Okay. This girl, her strategy is just to count the number of unit cubes used to make the cube. So she's breaking it into two layers. So her first layer and her second layer. And she's counting them 1, 2, 3, 4, 5, 6, 7, 8. Not necessarily in that order. But she's saying that this figure has 8 unit cubes in it. So the volume equals 8 cubic units. Or you could say volume equals 8 units cubed. That use that exponent 3 when you're doing volume because it's length, width, and height. You're talking about 3 dimensions. All right, next slide. All right, this young fella is trying to figure out the volume of this rectangular prism. I put a big blue box over the answer. Obviously, if you look ahead, you can see it. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So he broke it into 3 figures, which is another good strategy. They call that decomposing figures, breaking them down into smaller units. All right, continuing along here with the guided learning, these prisms are made up of unit cubes. Find the volume of each prism. So they kind of chunk this assignment for you. I'm thinking these bullet points. One layer has how many unit cubes. So it's hard to see the bottom layer. So you might be better off seeing the top layer. So it's 1, 2, 3, 4 is the length, and it's 1, 2, 3, 4 is the width. So if you think of like L times W, if you're just doing the area, 4 times 4 equals 16. So each layer should have 16 unit cubes. 4 layers have how many cubes? Well, then you can just say, okay, so the height is 1, 2, 3, 4. So this is actually a cube. So you can do 16 times your 4 is 64 units cubed would be your total. Let me erase this. Erase my work. Of course, if you're doing it in your workbook, you don't want to erase your work. Go ahead and leave that. Send a picture to your teacher. All right, so the volume of this thing is 64 cubic units. Go ahead and try to figure out the next one. I kind of guided you through that first one. I'm going to pause it. I suggest you pause it right here and figure out the next one, and we'll go through it together. All right, so you probably had a chance to do that. Let's decompose it. So let's just look at the top layer. You got 1, 2, 3, 4. 1, 2, 3, 4. So again, you're looking at 16 units per layer times 2 layers should be 32 cubic units. See if my math is right. And there you have it. Keep moving along here. Oops. Let's get rid of this. It won't let me. All right, so now we're getting into oddly shaped figures, kind of like my head. So if you're listening to this, maybe you just laughed at one of my dumb dad teacher jokes, my misshapen head. All right, back to work, Mr. Serpico. What is the volume of this solid? And I like how this young gentleman here did it. He just broke it down. He took this one, then he took the back three here, then he took this three here, and he took this three here, and then he just counted them up. So he really broke it down. So he has 10 cubic units or 10 unit cubes. Tomato, tomato, same thing. That's kind of how he broke this one down. Now I'm going to give you guys a chance to pause it and try to solve these bottom two. I'm having trouble moving my screen share memo there. Take a look at these bottom two. Try to decompose them like the young man and figure out the volume of 6 and 7. Go ahead and hit pause. This is page 289 in your textbook as well, if you want to follow along. But let's see what you guys, well, you can see how you did 8 and then 9. This one kind of looks like a letter E with an extra cubic unit on there. All right, let's keep rolling here. These are simple solids here. It looks like most of them. The first one is 8 cubic units. The middle one, 16. The third one is 8. The cube or solid has a lesser volume than a rectangular prism. The cube has the same volume as a solid, and then the rectangular prism has a greater volume than the cube or solid. So these are your choices when you're comparing. So we're calling this figure over here, we're calling this one just a solid because it's neither a cube nor a prism. It's just a solid. Looks like an upside down T, kind of misshapen again. All right, so let's take a look at some other solids down here and see. I finally was able to move that, huh? And see what the volume is and how you could compare them. So the first one is pretty straightforward. The volume of A is how many? Go ahead and figure that out. Look at your layers. Looks like there's 3, right? Pause it there. And how about you try to calculate A, B, and C? Calculate those volumes. And we'll come back together. All right. So if I were doing A, I would say 1, 2, 3. So one dimension is 3. And then I would go 1, 2, 3, 4 wide. Another dimension is 4. And then the height is 1, 2, 3. So I like to do volume equals length times width times height. So this would be 12 times 3, which would be 36. Let's see how I did there. Switch to my arrow. Okay, so 36 cubic units. B. B is a little more intricate. It's a little harder. I'm going to break it. I'm going to decompose this one. Mr. Mancini loves that word. All right. I'm going to decompose this one into 2 layers. So the top layer is 1, 2, 3. And that's wide, and it's 1, 2, 3 long. So length and width 3 times 3. So you got 9 cubic units for the top layer. And then this bottom layer, it's equivalent to a certain extent, and then it's got 1 extra row. So one other group of 3. So I'm going to go 9 and 12 should be 21. 21, does that sound right? Oops, I looked at C. I meant to go here. 21. That's all right. C is probably the easiest anyway, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you've got your three figures all broken down and labeled. I'm just going to get rid of my scratch here. All right. Number 11 says A has blank volume than B. So A has greater, because they want you to use these terms. A has a greater volume than B, right? Let's see. All right, go ahead and analyze 12 and 13. Pause it right here. Come back and go over it. All right, 12, B has a blank volume than C. B has a greater volume than C. You just look at your data and you can see B is 21, C is 10, and C has a blank volume than A. Should be lesser, right? Okay, great. I think I'm about at the point of the lesson, almost here, where I'm going to have you do some questions on your own. All right, so this is just another visual looking at volume of a figure. These are both 1 cubic centimeter and 1 cubic inch. These are our two main dimensions that we'll be using. And again, length, width, and height. Let me see if I can move this again. Up there, how's that? All right, so again, you're using a cubic foot here and a cubic meter. So you could do cubic inches, cubic meters, cubic feet, cubic centimeters, even cubic yards. And then this figure is really just an image to show you what we've been talking about for a better part of a week or so. Rectangular prism made up of 16 1-inch unit cubes. So the length, let me grab my pen, is 1, 2, 3, 4. The width is 1, 2, and the height is 1, 2. So you would do 4 times 2 times 2, and that would be 8 times 2, which would get you to the 16. And in this case, it's inches cubed. All right, how about this one? Go ahead and try to figure this one out. What's the length? What's the width? What's the height? And then multiply the length, the width, and the height together to get your volume. Pause it right there and solve. All right, you probably figured this one out. 5 by 3 by 3 for a total of 45 feet cubed, not squared. All right, one more image, one more practice, then you're on your own. You guys can practice. Looking at some solids, the left one looks like a rectangular prism. The right one looks like a solid, just oddly shaped. And then you compare the volume. So 9 centimeters cubed is greater than 7 centimeters squared. So 7, although it looks bigger because of the way it's positioned and the odd shape of it, all of these missing kind of gaps in the figure will allow that to be less than the solid. All right, now take a look at number 15. Try to decompose those, maybe break them into unit cubes or shapes and parts, and try to determine which has the greater volume. Pause it right here. Okay, so, whoops. First figure had a volume of 10 inches cubed. Second figure had a volume of 8 inches cubed. So you would say A has a greater volume than B. All right, you guys are ready to get some practice in. Enough talking from my talking misshapen head. It's time for you to do some workbook pages 201 and 202. Today is Thursday. We'll finish this up tomorrow. Maybe we'll have a little quick check on volume next week, and maybe do a couple lessons from either chapter. I think we go into chapter 10. We'll probably start that. All right. But had we had another week of school, we probably would have gone over a couple more lessons of 10 and 7. But neither one of those are fifth grade Common Core standards, so that's why they get pushed to the end. 14 was the last chapter we really wanted to finish together. Okay, so go ahead and do your practice pages in your workbook. Thanks for listening, and we love you guys. We miss you guys. Talk to you soon.